Myself Dr. Balram Chauhan, lecturer mathematics, Government Polytechnic Lucknow. We have to discuss here applied mathematics 2. In this lesson, we have discussed 3 dimension coordinate geometry to all diploma holders, diploma students in UP. There are 3 outcomes in the 3 dimension geometry. First is to find out position of any point in the space. Second is to find out the direction cosine and direction ratio of a line. Third is to find the angle between two lines. In the 3 dimension, first of all we discuss what is the phases in x, y, z axis. Let us write u x axis, y axis and z axis. This is origin. For this plane, as you know, in the 2 dimension geometry, 4 parts divided in x y plane, that is called first quadrant, second quadrant, third quadrant and fourth quadrant. In that similarly, in the 3 dimension we have 8 planes, that is called octant. First of all we discuss in these 8 planes. First is O x y z plane, second is O x dash y z plane, O x y z plane in this way in the positive direction, and say O x dash y z plane opposite of the x. Their sign all is in first case positive and in the x dash is negative and rest y and z are positive. Similarly, we discuss O x dash y dash z, this is minus minus and plus. Third is O x dash y dash z dash, all are negative. O x y dash z plus minus plus and O x y z dash, that is plus plus minus O x y dash z dash x plus minus minus O x dash y z dash minus plus plus. फॉर द साइन, साइन ज्ञात करने के लिए अगर एक्स वाई जेड सीधे सीधे हैं तो वहाँ पॉजिटिव होगा और जहाँ डैश यूज कर रहे हैं वहाँ पर ये निगेटिव साइन होगा. ये 8 प्लेन ऑक्टेंट कहलाते हैं 3 डायमेंशन ज्योमेट्री में, और इनको चूज करने के लिए सबसे आसान तरीका है कि वो एक्स वाई जेड इस तरह से लिखते जाएं, इनके डैश लिख लें, बाद में इनके साइंस अलोंग एक्स वाई जेड एक्सिस पुट कर सकते हैं. टू फाइंड आउट द डिस्टेंस बिटवीन 2 पॉइंट्स, in that case let us suppose we have to take 2 points P and Q having coordinate x1 y1 z1 and x2 y2 z2. In that case we draw a perpendicular from P and Q on xy plane at a point n and m. Also we draw perpendicular at the point P on QM cutting a point A. In that case we know from the distance between 2 points P n and m their coordinate d, as you know, under root in the 2 dimension geometry x2 minus x1 whole square plus y2 minus y1 whole square. Here nm equals to pa. Therefore, in triangle PAQ, in the triangle PAQ we have PQ square by the Pythagoras प्रमेय, PQ square equals to PA square plus QA square, where PA is equals to nm, that is x2 minus x1, and QA that is equals to mq minus am, that is y2 minus y1. Putting the value of this, we have nm square pq square equals to plus z2 minus z1 square, and putting the value of nm square from the equation 1, we have x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Therefore, pq equals to under root x2 minus x1 whole square y2 minus y1 whole square plus z2 minus z1 whole square. This is required distance between any two point in the space. This is well known formula to find out the distance in the space of any two points. If P is x1 y1 z1 and q is 0 0 0, that is it passes through the origin, then their distance is OP equals to under root x1 square plus y square plus z1 square. Now, to find the coordinates of the point dividing the joining of two points, let us write, we take any two points P and Q, this is ratio small m and this is small n. Then we draw a perpendicular at the point P, Q and R on the xy plane, cutting PL and PRN and QM. Here we have to take 2 points P having coordinate x1 y1 z1 and Q is a point having coordinate x2 y2 z2. In that case, R is a point cutting the point line PQ in the ratio of m and n. In that case, in the plane PLA and RNC and QMB, we have by the figure AC upon BC equals to PR upon RQ upon equals to m upon n, where OC minus OA upon OB minus OC equals to m upon n. Putting the value of OC, in that case OC here from O to C and OA this point, we get x minus x1 upon x2 minus x equals to m upon n. After simplification, we find the value of x, that is x equals to n x1 plus m x2 upon m plus n. Similarly, we can find the value of y, that is n y1 plus m y2 upon m plus n, and z equals to n z1 plus m z2 upon m plus n. This is the point x y z in the ratio of m and n. If we take m equals to n, means R is the midpoint of the line PQ. Therefore, in that case x equals to x1 plus x2 upon 2, y equals to y1 plus y2 upon 2 and z equals to z1 plus z2 upon 2. Second case is if R is outside of PQ, means m upon n, ratio of m upon n less than 0, that means m x2 minus n x2 upon m minus n, y equals to m y2 minus n y1 upon m minus n, and z is equals to m z2 minus n z1 upon m minus n. To find the coordinate of a centroid of a triangle, कोई भी त्रिभुज है उनके सेंट्राइड को कैसे निकालते हैं? लेट अस सपोज वी हैव टू 3 पॉइंट्स, A is x1 y1 z1, B x2 y2 z2, C x3 y3 z3. Then from the head A B C, we draw perpendicular on the opposite lines, that is D is a midpoint of V and C, and E is the midpoint of the A and C, and F is a midpoint of A and B. As you know well, the centroid is dividing in the 1:2, 1:2. In that case, coordinate of D is x2 plus x3 upon 2, y2 plus y3 upon 2, and z2 plus z3 upon 2 is the midpoint of BC at the point of D. Similarly, we have to find the point E and F as well. Therefore, the centroid 2 into, in that case 2 into this point and 1 into this point, that is 2 into x2 plus x3 upon 2 plus 1 into x1 upon 2 plus 3. Here 2 is equals to m and 1 is equals to n. In the previous case, जैसे पहले हमने किया था m रेशियो n में, ठीक वही फार्मूला यहाँ यूज किया गया है, वो 2:1 के लिए. In that case, similar way, 2 into y2 plus y3 upon 2 plus 1 into y1 upon 2 plus 1 and 2 into z2 plus z3 upon 2 plus 1 into z1 upon 2 plus 1. After simplification, we get x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3, z1 plus z2 plus z3 upon 3. This is the centroid of the G. This is the centroid of the G, that is sum of the all entries upon 3. Direction cosine, definition of direction cosine, we have a line AB in the 3 dimension x, y, z axis. We take a line AB, then we draw a perpendicular line OP parallel to AB, making an angle alpha along x axis, beta along y axis, and gamma along z axis. Then their cos alpha, cos beta, cos gamma is called direction cosine of the line AB. As you know well by the name दिक्कोज्या, मतलब डायरेक्शन कोसाइन मीन्स जो लाइन ए बी है उसका एक्स अक्ष के साथ अल्फा कोण बनाए, वाई अक्ष के साथ बीटा कोण और जेड अक्ष के साथ गामा कोण बना रहा है, तो उसका कास अल्फा, कास बीटा, कास गामा, ये डायरेक्शन कोसाइन कहलाता है लाइन ए बी का. मोस्ट इंपॉर्टेंट डेफिनेशन. डिस्कशन अलोंग एक्स एक्सिस, angle with x, y, z axis of the line AB. AB लाइन जब x अक्ष के साथ एंगल बनाएगी तो इसको इस डायरेक्शन में ड्रा करेंगे तो ये लाइन OX के समांतर उस केस में हो जाएगी AB लाइन पैरेलल टू OX. इन दैट केस AB line makes an angle 0 degree, in the y axis 90 degree and z axis is 90 degree. Here writing here only 0 degree, 90 degree, 90 degree. Then their direction cosine, we take cos angle, then cos 0, cos 90, cos 90. Putting the value 0 and 90, we get 1 0 0, means cos 0 1, cos 90 0. Similarly, angle with x, y, z axis, AB लाइन y अक्ष के साथ 90 डिग्री, x अक्ष के साथ 90 डिग्री, y अक्ष के साथ 0 डिग्री और z अक्ष के साथ 90 डिग्री बनाएगी। कैसे? जैसे ये लाइन ए बी है, इसको इतना प्रेस कर रहे हैं कि ये इस तरह पहुंच जा रही है। तो जब यह ए बी लाइन ओ एक्स ओ वाई के पैरेलल हो जाएगी तो यह एक्स अक्ष के साथ 90 डिग्री और वाई अक्ष के साथ 0 डिग्री और जेड अक्ष के साथ 90 डिग्री बनाएगी। तो उस केस में यह एंगल 90, 0 एंड 90, देन cos 90, cos 0, cos 90, that is 0, 1, 0. Similarly, along z axis x अक्ष के साथ 90, y अक्ष के साथ 90 और z अक्ष के साथ 0 डिग्री बनाएगी, 90, 90 एंड 0। कैसे? ये ओ बी लाइन है, अब इसको इस तरह से ट्विस्ट कर रहे हैं कि ये z अक्ष के पैरेलल हो जाए। इन दैट केस z अक्ष से 0 डिग्री बनाएगी और x अक्ष के साथ 90 और y अक्ष के साथ 90 डिग्री बनाएंगे। इन दैट केस cos 90 डिग्री, cos 90 and cos 0 degree, that is 0, 0, 1. This is the direction cosine along x, y and z axis. Similarly, if we take along x axis is denoted by direction cosine small l, along y axis is small m, along z axis is small n. That is, we write small l is equals to cos alpha, small m is equals to cos beta, small n is equals to cos gamma. Then l square plus m square plus n square is identity, that is cos square alpha plus cos square beta plus cos square gamma is equals to 1. Direction ratio, those quantity which are proportional to the direction cosine is called direction ratio. वह संख्या जो डायरेक्शन कोसाइन के प्रोपोर्शनल हो वो डायरेक्शन रेशियो कहलाती है। लेट एल इक्वल्स टू कास अल्फा, y इक्वल्स टू एम इक्वल्स टू कास बीटा एंड n इक्वल्स टू कास गामा आर प्रोपोर्शनल टू द स्मॉल ए बी सी, देन स्मॉल ए बी सी आर कॉल्ड डायरेक्शन रेशियोज, दैट इज एल अपॉन ए, दैट इज प्रोपोर्शनल टू एल प्रोपोर्शनल टू ए, implies L upon A is constant, you write K. Similarly, M proportional to B implies M upon B, again one constant, write K, and N proportional to C, N upon C is again K, writing here L upon A equals to M upon B equals to N upon C equals to K. K is a proportional constant. In that case, small a, small l equals to AK, small m equals to BK, small n equals to CK. After simplification, K square equals to K square into A square plus B square plus C square equals to A, implies that K equals to plus minus 1 upon under root A square plus B square plus C square. After simplification, we have L equals to A upon A into K, putting the value of K, we have AK, therefore L equals to plus minus L equals to AK, therefore A upon plus minus under root A square plus B square plus C square. Similarly, M equals to BK, that is putting the value of K plus minus B upon under root A square plus B square plus C square, and N equals to similarly N equals to CK, putting N equals to plus minus C upon A square plus B square plus C square. To find the direction cosine and direction ratio when 2 points on given a line, we have to find out the direction cosine and direction ratio of any 2 points which are given. Let us suppose P is, their coordinate is x1 y1 z1 and q is coordinate x2 y2 z2. Let ON from the point we draw a perpendicular on x axis is Pn and Qm. This is making an angle alpha. Then ON is x1, OM is x2, NM is OM minus ON, that is x2 minus x1. If the line OP makes an angle alpha along x axis, angle beta along y axis, angle gamma along z axis respectively, then in the triangle PAQ, in the triangle PAQ cos alpha, this is base upon hypotenuse, PA upon PQ, writing cos alpha PA upon PQ implies PQ is equals to PA cos alpha and PA is equals to NM, PA is equals to NM and that is x2 minus x1. Then therefore, cos alpha PA upon PQ and we get x2 minus x1 upon PQ, this is cos alpha. Similarly, along y axis cos beta y2 minus y1 upon PQ and cos gamma z2 minus z1 upon PQ. This is the direction cosine along x, y, z axis. Direction cosine of the line along x axis x2 minus x1 upon PQ, y2 minus y1 upon PQ, z2 minus z1 upon PQ and their direction ratio x2 minus x1, y2 minus y1, z2 minus z1. This is the main difference. Main differences between direction cosine and direction ratios is, in the direction cosine we divide their distances, in the direction ratios we take their coordinate differences. To find out the angle between two lines, let us suppose if L1 M1 N1 and L2 M2 N2 are direction cosine of the line, two lines making an angle theta, then cos theta is L1 L2 plus M1 N2 plus N1 N2. We find their direction cosine L1 is equals to A1 upon under root A1 square plus B1 square plus C1 square, similarly M1 and N1, and L2 is equals to A2 upon under root A2 square plus B2 square plus C2 square, similarly M2 and N2. Then putting the value we get cos theta is equals to A1 A2 plus B1 B2 plus C1 C2 upon under root A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. Two cases arises, if theta is equals to 90, then L1 L2 plus M1 M2 plus N1 N2 is equals to 0. This is direction cosine, this is direction cosine and this is direction ratios. A1 A2 plus B1 B2 plus C1 C2 is 0. If theta is equals to 0, then L1 upon L2 is equals to M1 upon M2 is equals to N1 upon N2 in case of direction cosine, and A upon A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2 in case of direction ratio, that is DC. direction cosine. In that case, in this case we have to two cases arising here, be direction cosine and direction ratios. So, we have to discuss only here कि डायरेक्शन कोसाइन और डायरेक्शन रेशियो जो आपके दे रहे हैं वो किस तरह से है। अगर डायरेक्शन रेशियोज दिए हैं, डायरेक्शन कोसाइन दिए हैं तो दिस कंडीशन को यूज करते हैं, और डायरेक्शन रेशियोज को दिए हैं, डायरेक्शन रेशियोज में ये कंडीशन को यूज करेंगे। अगर ये परपेंडिकुलर है, दोनों लाइन एक दूसरे के परपेंडिकुलर हैं, दिस इज एक्स एक्सिस and this is y axis and this is z axis, one line here and another, this is AB and CD, then their angle is theta. In that case, in this case we have discussed their direction cosine L1 M1 N1, that is the line, this is L1 M1 N1 and L2 M2 N2, and direction ratio, that is A1 B1 C1, here A2 B2 C2. In that case we have discussed two cases. One is theta is 90 degree, then this line is clearly perpendicular, this is making an angle theta, holds these two conditions. And if theta is 0, means this line AB coincide to the CD, makes an angle 0, theta is equals to 0, that is AB overlap to the CD. In that case L1 upon L2 is equals to M1 upon M2 is equals to N1 upon N2. In the direction cosine and direction ratio, A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2. This is more requirements using in the angle between two lines, and there are so many cases arising here discuss we have. Thank you.